Hey folks, today I'm going to explain how a double pole, double throw relay works. This is the one we're going to use, okay? This guy is, the model number is YJ2NLY, and I'm going to put the link in the description below for this. This comes as a unit, and then this is a mount for a rack mount. This is the relay itself, okay? So you don't need both of them, but the link that I have in the description below comes with both of them. Okay, this can actually be taken off like that, okay, and then put back on. Only goes on one way. I like having it on this mount because it makes the wiring easier with these screws. All right, so I want to explain how this works. First, let's look at this diagram here that we have. Okay, it kind of tells us a little bit of how this relay works. So what I want to do is I want to explain how this diagram works. Okay, a lot of people, when they look at it for the first time, it's a little bit confusing. So what I'm going to do is draw something on the paper here and kind of explain how it works, break it down for you. And then after we do that, I'm going to give you a real world example of how you'd wire this up and what you might use a relay like this for. Okay, so I've duplicated what is on the relay, the diagram over here on the left. Now, what I want to understand, I'm going to make a little bit simpler diagram drawing over here in a minute, but what I want people to understand when you're watching this video is that a relay is really an electronic switch. So it's a switch that, instead of being controlled by your finger, it's controlled by electricity. So when electricity is applied to it, it will turn on the switch, and when you take electricity away, it'll turn off the switch. All right, so in this case, the switch is controlled by pins 7 and 8. Whenever you apply electricity, voltage, to 7 and 8, the switch will turn on. And in the case of this DC relay, it doesn't really matter which way that electricity is applied. Okay, so this can be positive and this can be negative, or vice versa. All right, so what does this diagram up here mean? Well, what that means is, let's look at, we can look at this side first, the 1, 3, and 5. Okay, so what it means is, for, in the normal case, when the switch is not on, okay, the number 1 and the number 3, okay, when the switch is not on, number 1 will be connected to number 5, and there will be no connection between 3 and 5, okay? The same is true when the switch is not on, that you'll have 4, 2, and 6. And in this case, 2 will be connected to 6, okay? And there'll be no connection between 4 and 6, all right? That's when the switch is off. And if you remember, like I said over here, when there's electricity or voltage applied between 7 and 8, that's when you turn the switch on. When there's no electricity applied here, that means the switch is off. So when there's no circuit for 7 and 8, then this switch will be off, and that's what we'll have, okay? When we turn on the switch, the exact opposite is going to happen, all right? There will be no connection between 1 and 5, and there will be a connection between 3 and 5, okay? Same is true over here. There will be a connection between 4 and 6, and there will not be a connection between 2 and 6, and this is when the switch is on, okay? So that's simply basically how it works. Now, I want to go into an application for this that I'm actually using for my automatic chicken door, and I'm going to use a timer. Grab that real quick. Use a timer as my switch, all right? And that timer is going to be wired up to pin 7 and 8, and then all of this other stuff is going to be wired in such a way that will allow me to turn on and off my chicken door while, depending on what time it is. All right, so with this, we can actually, due to how this this relay is laid out, we can actually have current flowing through a circuit in one way when the switch is off, and in the other way when the switch is on. And I'll explain how that is in just 1 minute. Okay, so as I mentioned, I'm going to use this circuit, or this relay, to build a circuit to move this actuator up and down to open and close my chicken door based on this timer, which is going to act as a switch. So the way this actuator works is it has a positive and negative, and when you apply DC voltage in one direction, it will open, and when you apply it in the other direction, it will close. And the actuator stops automatically when it reaches, when it's fully retracted or when it's fully extended. All right. So in order to do that, this is the diagram I showed before of how the relay works. So when the relay is on, these connections are made, and when the relay is off, these connections are made. If you look down here, okay, what we want to do is these circles represent the actuator that I'm going to use. Okay, so let's slide this up a little bit, and maybe we can zoom in. Let's see. Okay, so get this out of the way. When the relay is off, like I said before, 5 is going to be connected to 1, and 6 is going to be connected to 2. If we wire up pin 2 to always be the negative, and wire up pin 1 to always be the positive, then we're going to have a voltage in this direction, okay, from positive to negative. Okay, so maybe the actuator will extend, maybe it'll retract at that voltage. All right. Then whichever one it does, we'll come over here and we'll look at this. When the relay is on, like I said before, 5 will be connected to 3, and 6 will be connected to 4. So that would mean that this positive from 4 is going to come through 6, and the negative from the 3 will come through the 5, and voltage will flow in that direction. Okay. So when the relay is on, the actuator will get voltage in one direction, and when it's off, it'll get voltage in the other direction. The next step is to actually wire all this up. That's what we're going to do next. Okay, so what I did is I converted our diagram here down to some dots, or what we're going to do is we're going to convert this diagram into a diagram that looks like this. The reason why I drew this to start with is that's kind of how this relay mount is laid out. And if you remember, I said it's going to be a lot easier to use this than use it when it's disconnected. So if you look closely, you can see there's little numbers next to the screws. Okay, so I can focus up better on that. There's number 2 there, and 1 there, and 3 there, okay, and 4 up there, and same thing on the other side, okay? And this is what it looks like, okay? So 3 is going to be here, 4 is going to be here, 1 is going to be here, 2 is going to be here, etc. 5, 6, okay? Now, if you notice something, if you look up on this diagram, okay, if you notice something, 2 and 1 are going to be connected to 6 and 5 when it's off. And in this case, 2 and 1 are here, which represents the top of this top layer, right? This top shelf. And then 4 and 3 are connected when the relay is on, which represents this bottom shelf. Okay, so maybe that will help you kind of remember these. And now we're going to show you how to wire it up. Okay, let me see if I can zoom in a little bit for this. Okay, so we're zoomed in. If you remember what I said, no matter what, we're going to have 3 always be negative, 2 always be negative, right? 4 always be positive, and 1 always be positive. So because of that, we can wire them together. So 3 is always going to be negative, and so is 2. So we can wire them directly together with a black line, negative line. Now I'm going to choose to have 8, because remember 7 and 8 is what controls our switch, whether the relay itself is on or off. Okay, so I'm going to choose 8 to be on the negative side. So I'm going to directly attach 8 to. Okay, and this is always going to be negative. This is symbol for ground. Okay, so it's always going to be negative. Now, we also said that 1 and 4 are always going to be positive, right? See right there, 1 and 4. So, in order to do that, we're going to use red, and we're going to connect 1 and 4, all right? And I am also going to connect almost made a mistake there. 1 and 4 are always going to be positive, always, okay? So these are always going to lead out to our positive side. All right, and in here is going to be our battery. So we're going to have a battery that's negative and positive, and that's how these are going to be energized. I'm going to leave number 7 for a minute, okay? We'll just wait a minute. We'll talk about number 7 in a second. For 6 and 5, those are going to switch between positive and negative. So I'm going to use blue, and those are going to be connected to our actuator. Okay, put a little A in there for our actuator. All right. Good. Now, number 7 is also going to be connected to positive. Because remember, 7 and 8 control the relay, whether it's on or off. And so for 7, what I'm going to do is, I'm also going to have it connected to positive, but I'm going to have it connected via a switch. Okay? And this switch is going to be controlled by that timer that I mentioned to you before. Okay? So little dots there on my timer. All right? So that's what we're going to do. Now, we're actually going to get some wire out, get the relay out, and wire this up. Okay, first we're going to tackle the black side, negative or ground side. Okay, we have, here we can see in the diagram, we have 2 connected to 3. All right, so 2 to 3, and we're just going to use this wire to do that. Okay, 2 right here, connected down to 3, just like that. And when you're doing this, I do recommend backing these screws off pretty far and then really cranking down and tighten them when you're tightening them up. So now we're going to connect 2 right here over to 8 right here, as we see in the diagram. Okay, that's what we're going to do next. Okay, so we connected 2. You see we have 2 wires going in there, and number 2 to 8. Now we need to connect 8 to the battery. Okay, so now we connected 8 over to the battery, as shown right here. This is my battery line. Okay, it's over here, and I just have an alligator clamp connected to it, and that alligator clamp is connected to the negative terminal of my battery. So now we've wired up all the negative side. Now all we need to do is 2 more things. We need to wire up 4 and 1 together, and then we need to wire 4 to the positive terminal of the battery. That's what we'll do next. Okay, so we connected 1 right here all the way over to 4, which is right here. And then we connected 4 up and over to the battery, which is what we see right here. This is going out to the battery. Okay. All right, now we have to wire in the switch, and the switch is going to be connected to number 7 and out to the battery as well. Okay, before I show you how I connect the switch to the relay, I want to show you how I wired up the switch. Okay, if you look on the back here, even though this is upside down, so we can turn it up right side up. Okay, if you look on the back here, this switch itself is actually a relay, so it requires some input power. So what I did is I took the red side, the positive side, and I wired these 2 together. Okay, I wired the plus side from that's going to go to the battery, and I connected it via a wire nut to one side of this switch. Doesn't matter which side. Either side is fine. Could be on pin 4 or pin 5. I use these little quick connect paddle style connectors. So I recommend getting those. I'll leave a link in the description below with those. And then both of these are connected together, okay, to this wire nut right here. And then this goes out to the battery. This could also connect, instead of going directly to the battery, this could also connect on our diagram here to number 4, pin number 4, which would be over here. All right, so that's another consideration you could do if you want to connect it there. Then from there, I have a black side that goes to the negative of the battery, which, as I mentioned before, could also be connected over here to number 8. Okay, number 8 in our diagram, which would be on the top here. Or, let's see, number 3 might have an open spot down here on the bottom. Okay, number 3, which would be number 3. You can connect this negative to that. And then this white wire is the other end of the switch, and that's what's going to go over here to 7. Unfortunately, a white marker on a white piece of paper wouldn't show up very well. But when this switch is closed, when I turn this switch on, it's going to close this circuit, and electricity is going to flow over to 7, close this relay, and swap the polarity of our actuator eventually. So that's how that's done. And now what I did is, I said I connected everything else to the battery, but that white wire that we were looking before goes right here. Okay, so this white wire that's on the back on pin 4 goes all the way out and around and connects to the white wire. It's going to be a bit of a mess over there with all the wires and everything else, but yeah, that's why I kind of have everything pushed to the side so it doesn't look all messy. Like I said, you could instead on this back connect this pin 2, okay, to one of the black wires, and this pin, and then pins 1 and 5, all right, to one of the red wires, maybe what's this, number 1 or number 4. Number 4 is a little busy, but maybe number 1. Okay, so that's that. Next, we're gonna connect the actually well, let's test it right now. So there's a manual button on here. This is normally a timer, which I haven't set yet, but there's a manual button here. So let's go ahead and test it. Right now it looks like it is off. So if we push this button here, so we see it on the video, now it's on auto, so apparently the timer means it's always off. I push it again, and there we go. Now it turns on, and we can even see the indicator on the relay. I push it again, turns off. So we know our relay is working. The only thing left to do is connect the actuator and do a final test. Okay, so this looks like a mess, but we've been over everything. We've been over every step. The only thing I've changed here is I did take this red wire that, as you mentioned, as you remember in the last step, was connected right here. See, connected here, and then this coil, and that went over to the battery, okay, which actually you can see over here. Now I have it going directly into pin 1 here, okay, so that will work too. I could have done the same with this black wire. I could have taken this black wire from pin 2 on the back here, and I could have plugged it into one of the open slots here. Each one of these screw holes can take 2 wires, and there's one down here that's pin 3, okay, right here. So I could have plugged it in there, but I didn't because there wasn't quite enough room. So just to show this real quick on the diagram, what we're looking at here is this switch right here is actually now connected, well, it's connected to pin 1, okay. Well, let's get the red one out. It's now connected to pin 1, okay, on one side of it, and it's now connected to the battery, okay, over here on the negative side. All right, you could do the same thing here where you just connect, you know, this side right here would go over to this positive side here. You connect the switch right there, okay? So again, not a big deal. Just make sure that when you're looking at the back of this, that you have it connected according to what it says in the previous, that I put in the previous step. Now let's test it. Got my actuator hooked up. The only thing I changed was I connected the actuator. So this is the actuator line. Got a lot of black wires over here. This is your actuator line, and it splits off into a positive and negative here. All right, try and zoom in there real quick. All right, so here, right here, in 5 and 6, just like we showed up here. Okay, 5 and 6. Now with the switch off, okay, actually it's in auto. With the switch off, it will stay in this closed position. When I turn the switch on, so it's still off, that's off. So it cycles between on, auto, and off. So now it's off, off. And now it's going to go back to auto. And then when I push this again, it'll turn on. And you even have a little indicator here. And you see that the actuator is going. The actuator will stop. We'll let that run. It's a all kinds of stuff over there. It's a 12-inch actuator. And without me doing anything, without the timer doing anything, it stops. And it'll stay in that position, and you can see this light stays on, showing it's at the extended point. Now, if you plug this all together, and the actuator just starts moving, and this switch is in the off or auto state, there's a little light down here that says it's on. If it's in the auto or off state, and the actuator extends anyways, that's actually fine. because that's how it's designed to work. If you don't like that behavior, you just switch these two cables. Take number 5 and put in number 6, and number 6 and put in number 5. Okay? And then when it's time to close it, when the timer hits a certain time, whatever you have this configured for, it will retract. And again, it will stop all the way without any intervention. It automatically stops as an internal switch on this actuator. And that's it. That's the entire video. I took you from beginning to end. I hope this last part wasn't too confusing. If it was, leave a question in the comment section below. I'll have links to all this stuff, Amazon links to all this stuff in the description below, as well as I'll find a place to put these diagrams and upload them to the web and put links to them there as well. So I appreciate your watching. Please give it a thumbs up, consider subscribing, and thanks for watching.